One table down, two to go. Now that we're done with our concerts table, let's start by clicking Reset to give us a nice clean canvas. And delete that comment again. Then, let's move on to creating our ticket holders table. If you'd like to take a stab at it yourself, pause me and see what you come up with. It should be mostly the same as what we did with the concerts table. Okay, here's what I came up with. First, we're going to create the table and name it Ticket Holders. Then we're going to add the ID column, give it an int data type, and then make it the primary key. Since we'll probably have more than 32,000 ticket holders, we can't use small int for the data type. Instead, we should use int, which will let us have just over 2 billion ticket holders. Next, let's declare the first name column as a varchar with space for up to 255 characters. Then let's copy and paste that line twice rename first name to last name, and first name to email, get rid of this last comma, and there we go. Let's run it. And now we've got a ticket holders table. Great work! Back in the query, let's copy and paste in the insert statements from the teacher's notes to give us some test data. Then let's run it. And right, if we want to recreate the table on each run, we'll need to start by dropping the table. Let's add a line at the top and type drop table ticket holders and a semicolon. And then try running it again. Perfect. Also, if we'd like to check what's in the table, we can always use a select statement. Below our insert statements, let's select everything from the ticket holders table. Select star from ticket holders. Then, if we run it again, we should be able to see what's in the table without needing to click on it. Perfect. We're almost done with this table. There's just one more thing we should talk about, and that's the ID column. Each time we insert a new row, we have to come up with a unique ID, which can be kind of a hassle. Luckily, SQL gives us an easy way to deal with this by using the auto-increment keyword. If you add auto-increment after an integer primary key, then anytime you try to insert null, it'll just give you the next number. Let's try it out. Let's add a space after primary key, and then type auto-increment. Then, instead of using IDs 1, 2, 3, and 4, let's go with 1, 2, null, and null. And if we run it, we get an error that auto-increment is only allowed on an integer primary key. You know how I've mentioned that SQLite doesn't use data types? Well, there is one exception, and it's the integer primary key. If you declare an integer primary key, SQLite will actually make sure that whatever goes in there is an integer. So it makes sense that auto-increment, which requires integers, would only be allowed on an integer primary key. Okay, let's change int to integer and try running it again. But now it's telling us that there's no ticket holders table. Since last time we got an error in our create table statement, the table was dropped, but it never got recreated. So now we're trying to drop a table that doesn't exist. Lucky for us, there's an easy solution that helps make testing a lot easier. In the drop table statement, right after the word table, we just need to add if exists to make it only drop the table if it actually exists. Let's run it. And now we can finally see our auto-increment in action. We didn't specify IDs for Dominic or Marcella, but thanks to auto-increment, the database was able to pick up where we left off and give us 3 and 4. Pretty cool, right? Now that we know how auto increment works, let's go ahead and use null for all the IDs instead of just the last two. Also, while we're changing things, just like we added if exists to the drop table statement, we can do something similar with the create table statement by adding if not exists before the table name. This way, we won't try to create any already existing tables. Alright, let's run this one more time to make sure everything works. And in the next video, we'll tie everything together with the tickets table.